For Unit 7, Lesson 4, so domain and range. So complete the following statements. This is from yesterday. X-intercept of a graph of relation is what coordinate with a value of 0? The y-coordinate. Okay, the y-intercept of a graph of relation has a x-coordinate with the value of 0. Okay, so we were just talking about to get things started. So the domain of the relationship is a set of all possible x values. So the key component for domain and range, and please do this, is understand that domain goes with your x's, okay, and range goes with y's. So domain is your, whatever your graph is, domain is whatever your x's can be, anything, any x value. Is there an x value I can't have for some reason? Okay, and then your y, or your range, is anything that the y can be. So what values of your y can you have, or can't have? Okay, and we're going to talk about specific situations when you can have them and you can't. All right. So, any questions on that? So, again, domain goes with your input, x. Range is your dependent, your output, y. Anything? That's okay, kind of straightforward. So, now what they want here is, they're giving you a list of values, okay, a list of points. State the domain. So, the domain would be all your what? Your x's. So your domain, so just put D, would be 1, 0, 3, 5, -3. That's your domain. Conversely, your range would be the y's. R, 2, 5, 8, 9, 2. You don't have to write the same number twice, so I'm not going to write 2 again, because I already have 2. Okay, and do the same thing for part B. So we got D, 3, 0, -3, 2, -8. Range, 3, 3, 3, and 9. So just 3 and 9 is my range, because I don't have to write 3 multiple times. Okay, so now we're going to do that. We're going to do domain and range from these pictures. Okay, now, what's the difference between B and C? Okay, B stops, C keeps going, that's important. What's the difference between A and B? This is what we kind of talked about when I was here on Wednesday. Good, continuous, Alex, good. This one's not continuous, this one is. So there's no value here. Okay, there's no value here, but on the other one there is. So we understand the difference? So this one, not continuous and stops, continuous and stops, keeps going. Okay, so when I tell you, what is your range for this one, or your domain? Let's do domain first. We'll do domain for all of them first. So in your mind, Taylor, what do you think your domain is for A? Again, this is a guess or your best idea. What do you think your domain is for A? So, -5. Okay, good. That's one of them. Okay, good. That's that one. So your domain is, you have -5 and you have 5, and that, what's next? Hold on here. Oh, sorry, that's 4. Yeah, -5's right here. So -4, 4, 3, -3. So we've got this one, this one, this one, and this one, and it just keeps going, right? 2, positive, negative, 1, positive, negative, and then 0. That's your domain. Okay. Now, that was a non-continuous problem, so there was actual specific points for the domain. How can we write B differently? Because can we write every domain number for B? We can't. It's continuous, right? So if we're going to be very picky, there'd be, on this one here, I could technically say, can't I, that there's a 2, there's a 2.2, there's a 2.22, 2.222. I can keep doing that forever, right? So we can't list the numbers individually now. So what do we need to use? Good. Greater, like, what are those called? Starts with an I. Inequalities. You want to use an inequality. Okay? So you want to use an inequality. So we can say our domain, x is between what two numbers? 4 and negative 4. X is greater than negative 4 and less than 4. Does that make sense? So how you write in between this inequality is you write x is greater than negative 4, x is less than 4. That's how you kind of write an in-between statement. Yes, Alex? It is. That's what I was getting to next. It's equal to because it's on those solid dots on those spots. So she's correct. It can be negative 4 and it can be 4. Any questions about inequality statement there? Okay, kind of makes sense. Okay, let's get to this one now. So what's my domain for this guy? Might stump you a little bit. Alex?
It's like x is greater than and less than.
You're technically right, but there's a way we can write that. How about this? Is there anything x can't be? 5? Well, I mean, the arrow goes past 5, doesn't it? Right? And their arrow, so we're under the assumption that this arrow means it goes forever. Right? And we're under the assumption that this one goes forever. So it's this simple. X is all real numbers. It's kind of an R with a line through it. All real numbers. X is anything you can think of that's a real number. Okay? Any questions with that one before we go into ranges? Okay, so now let's do the range. So this one's range, what do you get for Tatum? What's this one's range then on part A? So what are the y values that it is? So these numbers. Yep, it's 0. Okay, what else? 4. Okay, that's the top. Okay, what's about in between there? 3. Okay, good. 1. So 0 to 4, right? 0, 1, 2, 3, and 4. Very nice. Okay, Alex, what do you think the range is for B? Y. Yep. Okay. Good. So your range is between 0 and 4 for this one, for this continuous. Okay, so greater than or equal to 0, less than or equal to 4. Very good. Okay, and part C, what do you think, Janae, for part C? Okay, not quite. Right, because 4 stops. We don't ever get above here, right? Because it's always going down. So it's less than or equal to that highest point. The highest point is 4, so good. Less than or equal to 4. Is that good? That's a good one, because that's the one I kind of plan on you missing. But you'd still say all real numbers less than 4. So, Janae, you're not wrong. We seem to be less than 4. So, still Y, all real numbers. Okay. Moving on here, we only have 3 pages today, so that's page 1. All right, so example 3, state the domain and the range of the following relations. Okay, so I have these pictures here. We got a couple of graphs. We got a, what's this called again? Whoops. What's this guy called? Mapping diagram, yes. This guy, this is a parabola. Okay, that's a circle, and that's a circle. Okay, so we're going to do the domain and range of these. So we got domain. Is there anything, Molly, is there any, what's domain of the parabola here? Is there anything that x can't be? For this guy? Well, these arrows mean it goes forever. So that means it's going to go forever this way and forever this way. So, right, so it's all real numbers. So at domain is x is all real numbers. Okay. What is the range, Jad? So, Jad, I'll tell you that this point is at -3. So what's the range of that parabola? So the lowest point's -3. So how would we want to write what the y can be then? Good. Yep, that's it. So the lowest point's -3, so on everything above -3. That's the possibilities. Very nice. Okay, good. All right, back to Chris here. Chris, you want to take a shot at the domain for this circle? Okay, good. So it's -2 and 4. Okay, so you said greater than -2 and less than or equal to 4, right? Good. So that circle is between 2 and 4. So that what that means is any of these x's here, right in this area, are allowed because they make a point on the circle. Does anybody remember the definition of a function for Math 9? Is that circle, is that a function? What's the definition of a function? Every x can only have one y. So this x right here, 0, has two y's on a circle. It has two answers. That's not allowed. So circles are not functions. Just so you know. Okay. Range. So range, Taylor, what's the range of the circle? So it looks like the highest is 1, and I'll say the lowest is -3. Good. Positive, but yeah. Okay, good. All right, now using the mapping diagram. So now this is your x, these are your y's. So what's your domain, Tatum, for your mapping diagram? Yep, 1, 2, and 3. That's simple. Okay, and then what's your range, Alex? That's right, 2 and 6. Okay, a circle with a center, -2, 3, and a radius of 3. So what that means is we got 1, 2, 1, 2, 3. That means it goes 3 points in every direction. So it goes to here. 1, 2 goes to here. 1,